Thank you so much, Sergey. It's a pleasure to be here to talk to you all about this. I want to keep this interactive, so whenever you have questions, just stop me. There's no point in just going on without everybody on the same page. Thank you, Sergey. I'll give a brief intro about myself. I'm Sreeram. I've been a faculty member at the University of Washington, Seattle, where I run the UW Blockchain Research Lab. I've been working on blockchain stuff for the last 5 years. But my interest in peer-to-peer system dates far before that. My PhD was in peer-to-peer wireless networks, like back in 2006 to 11. So this project is called EigenLayer. So I've been on leave at our startup Layer Labs, where we build this project called EigenLayer. And what EigenLayer does is it allows people to add new features leveraging an existing trust network. Eigen in German for your own. EigenLayer is a mechanism by which anybody can build their own things on top of a common trust network. So the kind of like one way we think about it is it's a mechanism to empower distributed systems builders where they can come up with new things to build. They don't have to go and build a whole new layer one or a blockchain just for their one new technical idea. They can kind of leverage a large existing trust network to do this. So when you think about the underlying kind of like premise of this project is starts with this particular vision of or view of what Ethereum actually did. So if you look at kind of like the structure of Ethereum, you have a trust network, you have a consensus protocol, you have a programming layer on top, and but anybody can come and build new applications on top of it, right? Uniswap, ENS, Curve, whatever, right? Like all of these things can come and build on top of this. And the really crazy thing that it did is separate who brings trust from who brings innovation, right? DApp builders create new innovative solutions, but they don't have to build a new trust network all for their particular application. This was the state of the world pre-Ethereum. Right? So one way of thinking about Ethereum is, hey, they expanded the script or programming language, but I think that does not explain the scope of success of Ethereum. I think fundamentally what it did is to create a marketplace for decentralized trust. Essentially, trust is sold to the dApps. Uniswap is buying trust from Ethereum and paying a fee back to the Ethereum network. And by creating a marketplace for decentralized trust, it separated like who brings trust and who brings innovation and led to a massive rate of innovation. In fact, I would say that this is the driving feature or driving reason for why we have the kickoff of a pseudonymous economy, where you as a creator don't need to be trusted or reputed. You can be an anon and still kind of like leverage some of the benefits of having trust from this ecosystem. So this was awesome, but there are still many barriers to innovation. So trust. So one way to think about it is Ethereum unbundled trust, Bitcoin completely bundled trust, Ethereum somewhat unbundled trust and was able to supply it to others. But Ethereum still cannot supply trust. And I put all smart contract platforms at the same level. They all did the same thing after this. But if you wanted to go change anything in the core stack of the Ethereum protocol, like change the consensus, change the virtual machine, you can't do it, right? You have to go build a new blockchain just for that one change. I have a new consensus protocol, I have to go build a blockchain. I have a new virtual machine, I have to go build a blockchain. We see this emergence of like the Avalanche, the Solana, and all these blockchains, because it is simply impossible to leverage the trust network of Ethereum to actually do any of these other stuff. So I think this is how I think of like the era of the alternate layer ones. And but this is not all. Suppose even Ethereum was perfect as a blockchain and had the right virtual machine, consensus, scaling, everything. It only supplies trust on block production. right? Like Ethereum supplies trust to the dApps on block production. But to actually have a working dApp, we need a whole bunch of other things. We need oracles, we need bridges, we need sidechains, we need authentication services, we need event-driven actions, like a whole suite of them to actually get the dApps to work. And the problem is, on none of these things, Ethereum's trust network can supply trust. It's kind of limited in the dimensions in which it's able to supply trust. And for each of these new things, you need to have a whole new network to be built. For an oracle, for a bridge, for a sidechain, for a authentication, for a data availability, for an event-driven action, for MEV management, everything requires its own new network. And the problem with everything having its own network is proof of stake is one of these places where the cost of security is quite expensive, right? So for example, if you're a middleware, you have to actually put in a certain amount of staking in your system to actually like provide economic security. And this incurs a certain cost of capital. Imagine I'm running an oracle and I want to be as secure as Ethereum. So I need $20 billion stake. Okay, so if I want $20 billion stake, then you can ask like how much APR should I give the stakers in order to justify the staking? And maybe that's a 10% APR. If you want $20 billion at 10% APR, we're talking about $2 billion in annual revenue, either in hard cash or in speculative upside needs to be given. It's very expensive. So what ends up happening is most of the middleware will have much lesser trust models. And even though the dApps are kind of paying a higher fee for like living on Ethereum, for getting the trust, it is not getting the trust uniformly in all these directions. And at the end of the day, it's limited by the worst case trust. And finally, on the Ethereum side, it is misaligned with the core value proposition of Ethereum, because if the value proposition of Ethereum is to supply decentralized trust, there are all these islands of decentralized trust rather than one like superpower of decentralized trust. Okay, so how do we solve all these problems? We have this mechanism we call EigenLayer. EigenLayer is a restaking collector. What is restaking? Restaking is a new concept we came up with. And the idea is to put your stake at double jeopardy. Like you stake in Ethereum, right? You're a staker, you stake in Ethereum, you somehow put the same stake at additional risk on EigenLayer and supply it to anybody else who's building anything new on top. So what do I mean by all these things? Let me explain something concretely. So every new middleware, so I'm saying it's a middleware, but any service, this could be middlewares, this could be things like I want to build a new L1 with a new consensus protocol. This could be things like I want to build a bridging hub. This could be things like I want to build a secure multi-party network like Penumbra. Like it could be anything basically, right? And what do I mean by, you can get Ethereum trust is you basically, what do you need to do if you want to build it? You have a container which specifies what each node needs to run, right? Like, so each stakers will download and run this off-chain. This is just a Docker container, so you can write in whatever language and semantics that you're most interested in. On the other side, you can also create an on-chain set of smart contracts. So you basically say, hey, I'll actually build a smart contract which talks to the EigenLayer smart contracts. EigenLayer itself is just a series of smart contracts on Ethereum. It's not a new layer one. It doesn't have a new network, no consensus, nothing. Just a set of smart contracts on Ethereum. And what this does is it allows you to do three things. When you connect your smart contract for the middleware to EigenLayer, you're specifying what is the gating condition. What is the entry condition? If you stake ETH, if you restake ETH, can you participate? Or if you restake a liquid staking token, can you participate? You can specify these conditions. Number two, you can specify what the payment conditions are. Or whenever you serve 1 gigabyte of data, I'm going to pay you $1, whatever. And then there is a slashing condition, which is if you don't do the thing you're supposed to do, you may lose your money. So I'll take an example of data availability and make this clear. And data availability, what is the container doing? The container will open TCP connections, download some portions of data, send certificates saying that I have stored the data. What does the contract do? The contract will receive claims on, oh yeah, all these nodes together have stored 1 GB of data or 1 TB of data, whatever, and then make a certificate, which is very small and lives on Ethereum. And so that's the registration that data has been stored. Now you may have a game which says, oh, if randomly we will recall some set of nodes to come and produce their data, and they have to like post it on Ethereum, and if they don't post it, they'll get slashed. So that essentially enables the slashing conditions for this particular data availability layer. So each new middleware has to think about what do they want to do off-chain, what do they want to do on-chain, how are they going to hold the nodes accountable to what they said they are going to do. That's written in a hard, objective smart contract living on Ethereum. It's not some subjective judgment from some people deciding whether somebody is getting slashed or not. Hard smart contracts on Ethereum. Okay. So officially what's happening is EigenLayer stakers are opting in to some subset of these services. As a staker in Ethereum, you may say, I like data availability. I want to also run this hub, bridging hub. I want to run these 5 things. I opt into those 5 things and then I run it. So that's the kind of like basic structure of EigenLayer.
Yeah. So is this the right way to think about this? Which is, so today, if you want to spin up any of these services today, right? You know, it's fairly thick, right? You gotta create your own governance token. You gotta bootstrap a lot of those stuff. With this, you're essentially saying that all those overhead about providing your services, they're gone, right? You can leverage essentially what already exists in the ETH infrastructure. Just build your services and let people restake to you. You don't have to worry about that layer. Is that the right way to think about it?
That's absolutely what we're shooting for. Is you, just like AWS made it really easy for programmers to go and like plonk their code there and let it run on the cloud. We'll manage everything. The core value proposition of blockchain is decentralized trust. It's not just a computation layer that I can run on a single computer. It's decentralized trust and economic security. You borrow that from this massive network of validators, and we will make it really easy for anybody to come and throw their new services on top of this. So that's really the kind of like basic transformation that we want to do. Make building distributed systems as simple as building dApps, right? dApps are just like a very limited scope of what a general distributed system is. And so that's really what we're shooting for.
Got it. And I have one more follow-up question on that. Given that, and this may, and feel free to say this question it's irrelevant. Given that, is there any rehypothecation risk here? Because now you're using it multiple ways. So are you sort of quadratically embedding sort of runs or bank runs of certain type in the system?
It's a great question. So whenever we have leverage, we need to think about what the systemic risk is that we're creating. So absolutely, I'll address the risk management part in like a couple of slides. So please do remind me if I don't get that. I do have a slide on that.
And I guess just another question. Yeah. So, okay, you talk about like slashing and things like that, but a lot of this, services that are built around it, they also have pretty sophisticated like incentive models. So what happens with those, right, when payments are not enough to actually subsidize the cost for running all the hardware?
Yeah, it's a free market, it self-scales, right? Like so exactly what's happening is each middleware is specifying the set of incentives, right? Positive incentives and negative incentives. And if the set of positive incentives is not enough, then you won't have enough stake opt-in. And so you could have a situation where the fee is so low, nobody will opt in. So how do you build an economic model? I think this leads off into like a bigger question, which is how do you build an economic model around building a service on EigenLayer? As a middleware, what do you have? What is in it for you, right? I'll explain like the four models you can build on top of EigenLayer, economic models. The simplest or the purest one is, hey, there's going to be a fee for every byte of data stored. I'm going to use data availability just for simplicity. There's going to be a fee for every byte of data stored. And I, as a creator of this data availability service, I'm going to take 30% of the fee. I'm going to give 70% of the fee to the stakers. They're doing the operations. I'm doing the innovation. So I'm going to take 30% cut. And I have a wallet address written into my contract, and 30% of the fees goes to this. First incentive model. You can build like a pure company around this thing. You control the wallet, you control the fee, you have a future fee source, whatever. Number one. Number two is a more crypto native model. You say, okay, all these fees, who does it accrue to? Why is it accruing to a company? Can it accrue to a DAO? Okay, so fees go to a token DAO. Second model for middleware. Third model, fees accrue to a token DAO, and actually I'm not paying the stakers in the fee, but I'm paying the stakers in my native token. So it's a payment, is also a payment token or a payment currency. And then the fourth model, which is even deeper crypto native, would be something like dual staking. So one of the things that many of the middlewares want is a staking utility for their own token. And it's totally understandable because there are actually like two good reasons to have the native token to be staked. The one thing is, of course, it provides value accrual, liquidity sink, all these things to the token. So that's a well understood use case. But there's also a non-trivial crypto economics on top of like a native token. The ETH quorum only takes the risk as far as there is a kind of concrete objective slashing condition. But the middleware token takes a risk not only in terms of objective things, but also subjective things like, if the price of the token goes down, they take toxicity, and so they are aligned with the value proposition of the system. So it is better to stand on two legs, one with just pure economic value and the other is with value alignment, than stand on one leg. So most of the EigenLayer architecture is built around the dual quorum staking. What is dual quorum staking? You stake on Ethereum, you have each stakers stake with their own token, but you may also have your own ecosystem of stakers for staking your middleware token. And why would you do two tokens rather than one? Number one, I mentioned bootstrapping a new token is hard, right? Like when you want to go and build a whole new thing, you have to build an ecosystem, blah, blah. And that could be hard. And one of the things that EigenLayer allows you to do is to go start a new protocol without even having a token, and you can tokenize your position later. But you can also start with the dual quorum model from day one. And even if your quorum is only worth like, 50 million or something, it doesn't matter because you can still rent a lot of security from Ethereum. So that is a very powerful utility. But it's not only in bootstrapping, it is also in Equilibrium. There is a non-trivial value for having a dual token quorum. The reason you would want it is endogenous staking, especially if it's not diversified enough, can have negative death spirals, right? For whatever reason, there is some negative speculation on the token loses value. If the token loses value, it could start losing security. And as the system started losing economic security, dApps or integrations can leave. And leaving dApps or integrations means more negative speculation going off on a circle. So the dual token quorum is a mechanism to hedge against death spirals, have a certain amount of security under return without risk. So you basically have two sides. One side is the real cool thing is even if the token's worth zero, right? As long as there is non-zero fees being paid to the quorum, you can still maintain non-zero security. So you can actually say that like there are two sides on the balance. One is like you want to hedge against like these negative death spirals. Other is you want value accrual to your own protocol. And what you can do is you can tune a knob. And the knob says, am I paying 100% of fees to the ETH quorum, or am I paying 100% of fees to the middleware quorum? And you can say, yeah, maybe I pay 90% to the ETH quorum to begin with. Over time, I tune it out and I pay like 90% to the middleware quorum, but I still keep non-zero position. Maybe eventually I just make it zero to go to the ETH quorum. So it's a very smooth, simple, single interface on which you can do all of this, rather than having to go and build a special infrastructure to do all of this. So that's the value proposition and tokenomics to the middlewares. So you are getting the ETH quorum as a risk hedge, as a bootstrapping mechanism for trust, but you also have your own quorum. You decide what you're doing with it. We are just operating an open innovation platform. We don't want to say, you have to pay this much or whatever. And I think Sergey asked this question, what if the fees is too low? Yeah, if you tune the fees to zero, of course, all the ETH stakers going to leave. And that's exactly how it should be. It's a free market on that side. So you have to pay their incremental cost to actually participate in the system, and you can tune it on your system. So that's the
Got it. But sorry, just to be, kind of just to push back on this, right? Like I think like no middleware kind of has a model where fees are enough to cover the infrastructure costs, right? Like they're all subsidized, at least right now. Maybe in the long term,
it's not
like
clear. Actually, I would disagree with that. So let me
what's
explain.
example? Yeah.
Yeah, let me explain one major example. Let's say running a chain, right? Running Solana is the most computationally intensive chain, right? Let's look at this system. So running Solana is like, running one node per year, 10K maybe. Let's say there are 1,000 nodes, right? We're talking about $10 million annually to run the system. And let's take the counterpart of it, which is what is the capital cost for staking in Solana? Let's say you have 5 billion or 10 billion staked on Solana. The capital cost of it is actually like, 10% of 10 billion is 1 billion. So if you take the operational cost and capital cost today, the capital cost far outweighs any operational cost. I'm not saying there's no operational cost, but just looking at the relative value between capital cost and operational cost, the capital cost far outweighs operational cost. One way to see it heuristically from the market is how much staking service operators are able to take a cut on like fees, right? Ethereum, we're seeing like 7%, 8%. I think even this is high. Eventually, as the market stabilizes, you'll see this go down even more. So the point is that operational expenses are there, but they are not the dominant expenses of staking on a middleware. The dominant expenses of staking on a middleware are fundamentally the other costs, which is the capital costs. But to answer your question on bootstrapping, you may not even have that $10 million to cover it, and that's acceptable. That's why we're saying that you don't have to pay the fee in the in ETH. Even to the ETH quorum, you may be paying your fee in your own middleware token. And as long as they find the deal acceptable, they will opt in. And their marginal cost for the ETH stakers to opt in is not capital cost. It's purely operational cost. And this is the equation that we're trying to change.
Got it. And just another question. Does an ETH token need to be registered through the eigenvector? Every token needs to be registered, or
so anyway, it's a new middleware, right? Like each new middleware has a registration for, I need to stake this ERC20 token, right? So that's the registration process. And then you tether a smart contract which says, every byte has this much fee or whatever. And then so officially what is happening is the restakers are like abiding, or like the binding rule is written into this smart contract that tethers to the EigenLayer contracts. And there you specify the entry condition, which may be like, what is the staking needed? We need ETH quorum and we need a kind of Axelar quorum or whatever. And say, this is the payment condition, like every bridge input, whatever has this fee. This is the slashing condition. Or if you have this, but you execute this thing and it turns out to be different, you'll get slashed. So that's the kind of overall architecture of the system.
Got it. Okay, so it's essentially like an on-chain marketplace for supply and demand for those things that you're trying to match. That's
exactly how we think about it. There are many ways of like staking on EigenLayer. You can, before I get into it, I'll kind of like explain what I think are the different sources of yield today in crypto, right? You can stake in a base blockchain, right, in L1 and get some rewards. You can stake in a DeFi and get some rewards. And there is some staking in middleware, like Axelar or Graph or whatever. And these could be inside the same blockchain or in different blockchains, or they themselves are L1s. Like these boundaries are blurred. But at the end of the day, there are these three kinds of like yield sources. And one thing liquid staking did is to break any trade-off between staking. So there's a kind of competitive equilibrium between these things, right? If one of them is paying way more yield in real dollars than the other things, capital moves a lot into that particular like mode. And liquid staking was a mechanism to aggregate yield from both the base blockchain and DeFi, right? So you go and get a liquid staking token, and then you can take a liquid staking token and put it into DeFi. So you kind of get the best of both worlds. And what we are trying to build is we are trying to build yield cascades which go beyond this. So you can go and take ETH, put ETH into the stake. So I'll just focus on the last one. You can go and put ETH into Lido and get a staked ETH token, take the staked ETH and put it into DeFi, get a ETH to stake ETH LP token. And we know that the ETH to stake ETH LP token has like some minimal value in terms of, maybe it's at least 1 ETH. And so you can stake that on EigenLayer and, still earn non-zero yield. The reason I think validation yield is kind of a fundamentally different category than DeFi is usually you're taking some price risk and you're kind of underwriting the price risk and you're basically earning a value for that. On EigenLayer or in general in validation, there is a kind of information asymmetry. And the information asymmetry is if you're honest, you will not be slashed. Like, if you know that the protocol is correct, honest nodes never get slashed. So you're not taking any kind of fundamental risk on your money, whereas that is not obvious to a third party, and they're trusting that, oh, you put your money down and you lose your money if you don't behave correctly. So it's a mechanism for making credible commitments. And so we think that it's actually a genuinely new category of yield. And if the value proposition of blockchain is in supplying decentralized trust, this EigenLayer is just a mechanism to supply decentralized trust flexibly. So that's a kind of like overall picture of the yield cascade. So we find like that the marginal value or the marginal risk people are taking is reasonably small, and the marginal yield they're getting, if it's greater than the marginal work that people do, then people will opt in. So that's the basic dynamics of this platform. I'll now get into like Vaikit's question on systemic risk. Are we actually over leveraging these systems and going to kind of blow up the entire Ethereum ecosystem because of our, this kind of leverage? So I'm actually going to claim the exact opposite. Actually, if built correctly, EigenLayer significantly reduces system risk. So let's take an example. So there is the L1. If built wrongly, it can also lead to leverage risks. But if built correctly, it actually reduces system risk. So if you take the economics of today, so there's a dApp. Let's assume all the dApps depend on all these different systems. They depend on L1 for block validation, but they also depend on some middleware like bridges and oracles and others, each of which have some amount staked in their ecosystem. And now you ask, I want to go and corrupt this dApp. What is needed? Like, I want to steal money from this dApp. What do I need to attack? You need to attack the weakest link, right? Whichever one has the least amount of security. And you go and do that, and you can ask, like, what is the cost of it, and so on. So it's basically the min of all these things that you depend on. That's the cost of corruption today. Okay, what happens in an EigenLayer world? Let's take the maximal leverage position. What is the maximal leverage position? Every staker opted into everything, right? So looks like the most leveraged. Let's understand what happens in the most leveraged world. Firstly, you see the number I've written here is actually higher. The total amount staked is higher than the total amount staked on this side. Why is this? This is because, if you assume fee parity between the systems, you're able to sustain, let's assume that, you will be able to sustain a $10 billion yield only if you have 10%, annual fees. So you have $1 billion in fees here, you have 0.1 in fees here, 0.1 in fees here, 0.1 in fees here. So there's like 1.3 billion in fees that gets paid to the stakers. And at a 10% yield equilibrium, you will see more people stake because, there's 10% yield. So you get $13 billion stake. So firstly, there is more staked, okay, that or aggregated, actually just aggregated. It's just pooled security. Okay, so you have $13 billion stake. Now, if you want to attack any dApp, you have to corrupt one of the inputs. To corrupt any one of the inputs, you have to corrupt this massive quorum. Okay, so the cost of corruption went from the minimum of many systems to the sum of all these systems. Pooled security is superpower. In fact, this is a recurrent theme, right? If you go back to like before Ethereum, you could say, oh, how is this Ethereum system going to defend like all these different dApps? Why not each dApp go and build their own blockchain? In fact, that was the world before. There was no other way for them. What we saw is there's a massive tendency to say, hey, a common pooled security is better than like, segregated security, especially for people starting. And as people start and enter the system, they can compose with each other with minimal trust friction. So they all aggregate on a common layer. So our view is actually aggregated security is significantly better. To take an L1 state example, right? People use this L1 as a nation state type example. And if you use this kind of an example, it's clear that a nation state having security is better than city state having security. A NATO having security is better than a nation state having security. So we see this like scale aggregation quite a bit. And it's exactly the same thing here. To make it more concrete, there is more hardening in staking, even in just like this limited context. Imagine like, you start aggregating, tens of billions of dollars and they power all these different dApps. And let's assume for now, there is some kind of over leverage. The total value of this dApps is maybe even more, maybe it's 100 billion, right? And you would say, oh, are we over leveraged? Yes, we are over leveraged. Actually, Ethereum is over leveraged today, right? Like it's $200 billion secured by like a $20 billion. And why is this okay? Because security hardens, right? To do an attack, the cost of attack is actually you have to burn like $20 billion and they'll get slashed, right? So the cost of attack is pre-specified. But the gain from the attack may not be 20 billion, right? Because who knows if you'll be able to make away with it. There are social systems which prevent you from like making away with all these other money. So there is actually like a scale hardening on security here, which is there's a nonlinear benefit. After some point, you get like, oh, you got a lot of security. You don't need to have more security. So these two effects together actually suggest that aggregated pooled security is actually like quite valuable. So that's what we are shooting for with EigenLayer. And that's why we think it actually reduces system risk rather than increasing system risk. Another mental model to think about is right now, if you think of L1 nation state, only one border of this nation state is protected by the army, block validation. But all these other borders, oracles, bridges, all these other things are left open for attack. And, people are installing new armies to defend against each of these things. But instead, if you had like a coordinated army, you actually have much better security system. So that's at least our view on why we think the system risk is lower. Having said this, there is one dimension in which there is a risk cascade. And that is if slashing is done improperly. Here we are assuming that slashing happens because stakers are malicious. But what if the contracts had bugs or the contracts are malicious, slashing contracts are malicious? It could lead to absolute mayhem because you're not having containerized risks. So how do we deal with that? That's the next thing we look at.
And I guess, sorry, just one more question there. I mean, here you assume, right, that like if you remove the middleware value, it gets added to the L1 value, which is, not immediately clear, right? Like, the
It's
fact
not,
that like
but
I'm saying like,
marginal
okay,
additivity that you will have due to any additional fee stream is going to increase the amount of staking. So you can definitely be assured that even though this value 13 may not be sum of 10 plus 1 plus 1, maybe 10 plus 0.5 plus 0.5, depending on what the quorum adjustment and other things we saw in the last slide are. But it is at least 10, right? And even at 10,
Sure.
You're getting a max rather than the min.
Sure, yeah.
Okay, so the I wanted to address one other thing, which is risk cascades and protections. 1 second, I'll switch to that slide. Any questions till now before I get there? Others? Okay, so here is the core problem on EigenLayer is there is a risk of improper slashing. What if some contracts were buggy, right, or return maliciously, though, so that they'll trigger slashing of every staker? That could be absolute disaster. How do we mitigate this? We have a subjective layer built on top of EigenLayer, which is a slashing veto. So the only thing this subjective layer can do is to veto slashings, right? It's to veto slashings. And who is doing this? It's not a token committee, because a token committee has a certain cost of corruption. Is done by basically prominent members from the Ethereum ecosystem. Is a reputational committee that can just veto slashing. How do we reason about something like this? The kind of core functionality of this committee is to say that if there is a kind of improper slashing event, we can veto this slashing. right? And that's what this committee does. And so who's taking a risk on this committee? The stakers are getting protected because of this committee, right? Slashing only happens if slashing is triggered by the contract and kind of approved by the committee or not vetoed by the committee. And who's taking a risk on this committee is middlewares, right? When you're building a middleware, you may be like, hey, I thought I got some security, but this committee may be rogue and I don't get security from this committee. So that's the side that is actually taking a risk on this committee. And the way we reason about this is we want to have two grades of middlewares on top of EigenLayer. One is in the initial phases, when the contracts are not yet vetted and like fully tested, this is kind of like layer 2 solutions initially need to have governance protections. And eventually you can remove the training wheels and ossify. So we have two grades of middleware on EigenLayer, one which is subject to the slashing veto and another which is not subject to the slashing veto. And anybody can build on any of these two things. But if you build a service which is not subject to the slashing veto, you have to convince the stakers why they have to take an additional risk and like put their money into your contract, which may be buggy and they may get slashed and lose their money. And by having this two-tier system, we can actually have both a protected layer where stakers can just feel comfortable that they have like a protection on slashing, as well as a layer where like people can kind of build their own things, but they are now responsible to convince the stakers that the additional risk they're taking is actually worth it. So there's more governance details to it. I won't get into it right now. But that's the basic idea of like risk management on EigenLayer. Okay, next I'm going to talk about like, okay, you have an ecosystem like this. What can you build on top? I'll spend like maybe 5 to 10 minutes trying to kind of explain what you can build on top of this. Theoretically, you can build anything on top of this, right? You can imagine a network of trusted execution environments which have hardware requirements. Only nodes which have that hardware requirement can opt in. You can have GPU systems where like some set of nodes need to do GPU for ZK proofs or whatever, but they're putting the stake from Ethereum. You can have simpler systems like, data availability. You can have bridges. You can have a whole bunch of systems built on top. So theoretically, a secure multi-party computation, any of these things. So theoretically, you can build anything on top. But what is the compass that we're using to navigate? Like, what are the most interesting things to be built on top? So because, one of the other value propositions of building on top of EigenLayer is ecosystem alignment, right? You want to build services which are kind of useful to the Ethereum ecosystem. And if you build it on E3 staking, it's kind of naturally aligns all the parties in the system because the E3 stakers are now getting exposure to your token. And, so that's actually like a net positive. You're buying trust and, you're exchanging equity in your system or tokens in your system. So, okay.
I'm sorry, just another quick question there. Though, so you said theoretically you can build anything on top, but so if I'm building something that requires actually like an external consensus, right? It's like a pretty hairy system. So how is it going to work? Is that consensus going to be run across your like container pods or?
Yes. Yes. Okay. So the consensus is entirely run across the container pods. There is no like tethering to the Ethereum blockchain, except on Ethereum blockchain, you can have a slashing contract for your L1, which says that if somebody double signs something or whatever, they'll get slashed, right? So the slashing contract is the only thing that is resident on Ethereum. And there should be enough state maintained in the slashing contract to make sure that it knows, whether a slashing is correct or wrong.
And so what is the consensus that you run across?
You can run whatever on the container.
So it's up to me to implement that consensus then?
You're free to implement whatever.
Okay, got it.
Right. So you can run a Solana on top. You can run an Aptos or Sui or Axelar, whatever.
But like all this consensus, if I need a consensus, then like, potential like membership changes within that are pretty complex, right? Like, so
membership changes need to be logged to the Ethereum contract, whether it's like a hash or whatever. There's a light client maintained on chain. There should be some enough state in this contract to actually know if it can slash correctly and if it can pay correctly. So so this is up to each of the protocols to design it correctly, but I think it's possible.
Okay, got it. So if I have like a very big validator set, like, like sort of avalanche type of consensus, then that could get pretty expensive sort of on chain.
We don't need to maintain the validator set on chain. You could just maintain commitments to the validator set on chain. And as long as nobody is challenging it, you would continue to keep it.
Then you assume in some type of, fraud proofs or.
Yes, there is. So that's one of our core patterns for how we think about slashing is basically some kind of fraud proofs.
Okay.
It's what actually drives these slashing contracts so that you don't have to do a lot of state maintenance on chain. The nice thing is, even though there is fraud proofs, you don't have the associated latency because you have a large economic quorum underwriting it immediately, right, on off-chain. And so you can take it as the correct answer and keep going on. But if they did something wrong, it's just a mechanism before the stakers exit the system, they can be slashed. So that's why we think it's a reasonable pattern. So the attendant like headache with fraud proofs is the latency, right? But because you have a large economic quorum underwriting the system, you don't need to worry about the latency. It's just the latency is there for staking exit, right? That's all that latency translates to.
Okay, thanks.
Okay, so now I'm going to go to the example type of systems we can build on top of EigenLayer. So, Ethereum has chosen to kind of like build a modular blockchain stack. So we can ask the question like, what are the advantages and disadvantages? And can we kind of plug all the disadvantages? One way we think of EigenLayer is the necessary, like almost all of the other, like at least base L1 ecosystems have kind of like thought of themselves as, hey, I'm bringing this new technical advantage, right? And one way we think about EigenLayer is a mechanism to like bring any technology on top of this trust network. And so we can think about like, oh, what are the ways in which like other ecosystems have advantages and how we can kind of build it on top of this trust network. So one thing is like to start with, the advantage of a roll-up world is it kind of moves computation and memory off chain. So you can kind of like do a lot of it, but still all the data needs to be returned into Ethereum. So the data bandwidth is a major problem. And even with upcoming upgrades, the data bandwidth of Ethereum is like rather low, 80 kilobytes per second. And we think, I remember 1994, I got my first modem, which was 56 kbps. And we're talking about a world computer in 2024 running at 80 kilobytes per second, just like simply unacceptable. So data bandwidth, we need to increase this massively. The other thing which also is a big problem with Ethereum is the slow finalization time. Block time is 12 seconds. Maybe that's okay. Even that, like Aptos and Sui are talking about 1 second. And here we are talking about finality at 12 minutes, right? So it's really slow. And really slow also means it's a pain for bridges, right? Like if you want to bridge state, if you don't have finality and you make statements elsewhere, how do you deal with forking? It's really hairy. So the other problem is, when you have a roll-up, you need a node that orders all the transactions and then makes commitments. Ordering can be kind of rely on decentralized sequencing rather than centralized sequencing. The other thing is, I think one of the values of Ethereum, which I don't think people have fully understood or exploited yet, is even in a multi-chain world, it has kind of a prime position as a hub. And the reason is, I think, what are the features of a hub, right? Like it has high connectivity, it has high liquidity, it has high security. And Ethereum has all of these. It just has very low quality bridges right now. And so this is another thing we see is lacking in the Ethereum ecosystem. And finally, we see things like Osmosis and Penumbra coming with much more sophisticated MEV management in Cosmos. And Ethereum is just starting to figure out like how to do all these things. So how can we solve all these problems? Okay, I'm going to lay out a little bit of a grand vision for what can be built on EigenLayer. We know it's a little bit complex, but I think it's a possibility. Okay, so what is happening is ETH staking powers Ethereum, but it also powers EigenLayer if we have a lot of stake restaked. And imagine in a lot of stake restaked world, what all things can you do? Okay, first is, this is a crazy thing. If block proposals are restaked on EigenLayer, they can commit to block ordering rules. They can commit to block ordering rules. Okay, they can say, for example, I'm going to sell you a portion of my block and you have to pay a fee for it. They can say that I'm going to trigger event-driven actions, because if you suffer a liquidation, I'm going to actually execute it. And if I don't execute it, I'll get slashed. They can commit to, if there is an atomic arbitrage between Uniswap and Sushi Swap, I have to close it and pass 50% of the value back to Uni and Sushi tokens. So you can start committing to like very powerful. You can commit to, hey, I'm going to actually, whenever I sign off on an encrypted transaction, if I don't include the decrypted transaction, I'm going to be slashed. So you can build a very large suite of ordering services on top of EigenLayer. Credible commitments to transaction ordering that anybody can start writing these new solutions and capture a value. For example, by creating a lane where there is no sandwich attacks, you can charge the users a premium, right? Because you've credibly committed that if you actually don't include these encrypted transactions, you'll get slashed. So users will be willing to pay a premium for that. So you can charge them for it. So there is a whole suite of MEV services that can be built on top of EigenLayer. We are ourselves building the first service on top of EigenLayer, which I think, is the first problem I mentioned in the last slide, which is the scale problem of Ethereum. Data throughput is right now at 80 kilobytes per second. We are building a layer where we are already running 15 megabytes per second, but have a roadmap to get to gigabytes per second in like 2 to 3 years. So this service can underwrite a lot of other things going on, because data availability is one of those things that shows up everywhere, even actually in MEV management. If you want to know that a builder is sending a block and you want to accept that block, you need to know that the data is available for that block. Today, that is done by a trusted node called relays. And you can decentralize the relay using EigenLayer. You can start doing very powerful things if you have a highly performant data availability layer. So that's exactly what we've built. You can start thinking about, why is every rollup needing to have like a sequencer? Why not have and the nice thing is state execution. So rollup sequencers do two things. They do state execution and state proving. And the other side is they do transaction ordering. Transaction ordering is a roughly stateless operation. State execution and state proofs require a lot of state. So you can actually run state transaction ordering on a common decentralized layer and just outsource execution to the rollup nodes. And that can be done on a single node, because state execution is not contentious, because you can prove in zero knowledge that that's correct, or through fraud proofs that that is correct. Transaction ordering is contentious, and that's where you need like a decentralized layer. So this was the DYDX problem. They had to leave Ethereum because, I have decentralized sequencer. Now, if there's a decentralized sequencer run by the ETH stakers with the same type of guarantees and the same type of decentralization, it becomes very, very powerful. You don't need to do it. And as a state executor, you have no choice but to comply by the order of transactions that is spit out by that layer, because otherwise you'll get slashed. So it provides all kinds of like geographical arbitrage, decentralization benefits, liability, all of these things are transferred to a decentralized layer rather than a single centralized node. And, a rollup can kind of like input the ordering from the sequencing layer and then like commit to a blob, and that blob can be returned into the data availability layer. You get a certificate, you can write that certificate onto Ethereum, or like I said, Ethereum has major problems in finality. So it takes 12 minutes to get finality. And if you're a rollup and you want to send like very powerful economic confirmation to your nodes, you don't want to wait 12 minutes to get finality certificates. So what can you do? You can build an intermediate layer, like a layer 1.5, in between Ethereum and the rollup, which settles transactions. If you had a large amount of restaking on this layer, you can get, and this layer can run like Tendermint or, Narwhal and Tusk or Bullshark or whatever latest consensus protocol, SUI or Aptos or the new layer ones can use. You can use that in this layer and get finality, which is really, really fast. Not only that, there are a lot of benefits of doing settlement, ZK proof settlement, for example, in a special purpose layer rather than Ethereum. On Ethereum, for example, if you write more than 15 ZK proofs, you will run out of like block space in a given block. So you can, if you wanted every block to settle, then basically you can only run 15 rollups. It's a very limited architecture. Whereas on verifying ZK proofs is actually like a few milliseconds. So if you had an off-chain bare metal C++ implementation, you can just parallelize and verify like tens of ZK proofs on 10 cores or 16 cores. So you can do like a lot more throughput, lot lower latency. And this layer itself settles back to Ethereum in a slow manner. But the assurance you get is as soon as this layer issues you a certificate, you know that there is a massive economic security behind it, because if not, like a huge amount of stake is getting slashed on Ethereum. You can start building light client bridges, right? It's very difficult to run light client bridges on chain, but you can run light client bridges off chain really easily. You run light clients off chain, I was discussing this with Sergey, and Sergey's like, most chains don't have light clients, and it's true, and it's a problem. But to the chains that do have light clients, you can actually run it. And you can, for example, many Cosmos chains, right? So you can run it, and then you can actually input just the state or state root of all these different chains into Ethereum. And you make a claim that that is correct. And if somebody challenges that claim, only then the kind of execution of the IBC or IBC signatures, it gets executed on chain. So this is like a huge economic security underwriting these bridges. And so you can kind of like build a whole architecture. I put Eigen as a prefix in many of these things. Doesn't mean we want to build it. We want other people to build it, but it's just powered by kind of security from EigenLayer. I didn't want to draw all these edges. So,
is there anything in your implementation specific to Ethereum? Because you said it's a set of contracts. So is it specific to Ethereum slashing, or like
no, there is nothing specific. So what is specific to Ethereum is we are deploying it on top of Ethereum. That's right now that's the level of specificity. And it kind of like uses particular features of Ethereum staking right now, but it's possible to build this on any chain. So restaking is a kind of general purpose primitive. We have chosen to build on Ethereum just because we think there is most amount of capital, most amount of decentralization, and like a shelling point on Ethereum. But and also, first building on one chain is better. So that's.
Got it. And sorry, I know I asked you over the email, but I didn't quite understand the answer. The difference between like building something like this on top of liquid staking, right, protocol, right, like I guess like what I meant. So you have liquid staking, stake is liquid. You could do anything with it. You can build kind of EigenLayer like functionality in smart contracts to do something with that liquid staking token. Versus this, yeah. So
that is right. So when we talk about restaking, I was maybe a little bit vague. We have many modes of restaking. One is we call native restaking. Okay, what is native restaking? You stake in Ethereum, just natively. You're not sending your stake to anybody else. You stake in Ethereum and set the withdrawal credentials to EigenLayer. So withdrawal credentials in Ethereum is when you stake, you specify who has the power to withdraw from the contracts, from the base staking contracts. And you set that to the EigenLayer contracts. What you can do is the EigenLayer smart contracts, if you behave badly, can withdraw your stake and slash you, right? So that's the power that you're transferring to EigenLayer. The cool thing about this is, unlike liquid staking, right, which requires you to take a principal agent problem, you have to trust the liquid staking to do your thing, and you don't want to do it yourself. Native restaking does not have this problem. And this is kind of most obvious if you think about things like exchanges. Okay, if you're Coinbase and you want to kind of control who stakes and what and so on, is much easier for you to say, yes, actually, I know the smart contract. I am the staker on Ethereum, but I'm also the staking service operator on all these different services. It's just an extension of the staking protocol. I control it. I opt in. I can manage my own risk. As opposed to if you only allow liquid staking protocols to opt in, you will not be able to get these set of users. Having said that, EigenLayer itself supports both native restaking and liquid staking protocols and superfluid staking. So superfluid is basically you take like a Lido stake to ETH LP token and you can stake that on EigenLayer. You can stake anything on EigenLayer, right? It's just the interchain security hub of Ethereum. It's the interchain security hub of Ethereum. And the way we think about interchain security is it's opt-in at a validator level. That's a true free market, right? It is not opt-in at a chain level. There is no governance. There's no upgrade. Ethereum governance doesn't have to know about it or do anything about it. It's opt-in at a staker level. So it's essentially just interchain security built for Ethereum, opt-in at a validator level, and powered by the recent both merge, which moves to proof of stake, and the power of EVM fraud proofs, which Optimism and Arbitrum and the generalized, fraud-proof execution ability that we right now have on Ethereum. So that's the set of things that conspire to make this possible. And you could have an alternative layer, a competing layer, which just does, I just do liquid staking, restaking for my service, right? I just want to take stake ETH and I want to run my service. You could absolutely do that. But then you're competing for yield against an aggregated engine, okay? So imagine there are two layers. One has, because the thing with EigenLayer restaking is you're not restaking for one particular thing. You could restake for all of these things. And that's the equilibrium we want to get to, is a lot of people restake for a lot of things. And now if you imagine that world, if you have like one world where one system where ETH stakers opt in and get yield from like 30 services, and another system where ETH stakers have to opt in and get yield from only one service, the second system is going to have much lower stake than the first system. So aggregated pooled security versus like non-pooled security. So that's the set of like forces that make EigenLayer a force, even when there is a lot of liquid staking, and you could choose to do basically like specific restaking for one service. Any questions or comments? I think we are kind of at the natural conclusion of this talk, as well as coming up on time.
Awesome. I guess maybe just one question, like what's the latest in terms of development? Is there a testnet to play with, anything?
Yeah, so our deployment plan is right now, we want to test like the one service we've already built, EigenDA, and we are kind of like launching mainly with this service. So we have a testnet where if rollups can integrate with EigenDA, and this is an internal testnet, not a public testnet. Rollups can integrate with EigenDA and check like how to do this. And we're talking to stakers who will then try installing and like playing with the EigenDA containers. We will slowly start in the coming like 2 months, we'll start releasing some of our like EigenLayer contracts. So people who want to kind of understand how to integrate general middleware with EigenLayer can start thinking about it. But we are not launching with all the services on day one. We will launch with our own like first test service, right, which is DA. And as we on mainnet, in a few months after that, we'll start onboarding other close partners and services.
And what does the development look like for me if I want to build a service? There's a Docker container. I'm going to go, and just kind of modify it as I wish, essentially, or is there more?
That is correct. That is correct. So right now, the core development pipeline is you build your own Docker container, you build a set of smart contracts that can kind of like adjudicate faults and payments on these external services. So that's the only thing that is the only thing for which you have to understand the EigenLayer contract interfaces to deploy your own contracts that kind of talk to your own container and make sure that the system is kept in checks and balances. So the Docker container and the off-chain execution is totally freewheel. We are thinking through like what set of monitoring and other services that need to be tethered to it, and what the staker experiences. Do we kind of integrate with things like bicentrails type like staking interfaces, or do we kind of build our own? So we are a little bit early on the general purpose staking side, but right now the thinking is you can actually deploy arbitrary Docker containers for off-chains. So most of the distributed system logic is anyway in the container, but the middlewares or L1s or services have to build a contract. And for that, we will start releasing more information about contract structure, interfaces, prototypes of like examples of, hey, how do you build a bridge like this, and so on. So that's in the coming maybe 2-3 months.
Makes sense. Awesome. Yeah, just 2 cents of feedback. I think like our validators would start with containers, and they mostly requested bare metal implementations. So we actually stopped supporting, Docker, because they all want to run on bare metal and configure their own deployments.
Okay. Oh, that is a good point. Okay. we should think about that a bit more. Basically, this is performance reasons or like control.
I think control.
Control.
Yeah. Their own deployments, they compile from the source and like things like that.
I see. I see. Okay. Yeah, we need to think through that. Thank you. Any other like questions or comments?
I had a question that I'm not sure if this is a silly question, but is the notion of using this fraud proof baked into the protocol? I.e., if I'm running my distributed system on top of EigenLayer, is that the only model for consensus I'm able to use?
What do you mean by only model for consensus? You do whatever consensus you want, and the thing that holds the system accountable is the on-chain fraud proof. But the system itself is running whatever consensus that they are running, and neither the latency nor throughput nor any of the nominal parameters are affected by this fraud proof.
Okay, so it's just the slashing relies on the liveness of
That's right.
Ethereum,
That's right.
basically.
Right? Like normally you may have like your own either social slashing or algorithmic slashing in your protocol, right? But here, since we are relying on ETH, you cannot rely on social slashing of ETH for your protocol. So you're just doing it algorithmically. And that's the only thing that needs to be like codified on Ethereum.
Okay, makes sense.
Other than that, all consensus happens emergent out of the interaction between these containers talking to each
other. Okay, thanks.
Thank you, Jackson. Any other questions? I'm happy to stay for a few more minutes to answer.
Well, this was super good. Thanks so much for joining us and walking through this, Sreeram.
Thank you so much, Sergey. Super fun talking to the Axelar team. Looking forward to like possible things to talk about in the future.
Likewise. Awesome. Thank you.
Thank you.
Awesome stuff.
Okay.
Thanks, Sreeram.
Thanks so much.
Thank you.